Hi, this is Mr. Max. I am doing solids with uniform cross section. Now, this is also sometimes also an extension of mensuration where you're dealing with volume and area. So this is part one of a three-part video series that I'm going to give. So let me bring in a few things that you just have to quickly remember when I talk about solids with no uniform cross section. If you look at this cylinder here, or the step like thing here, this shape here, you can see that it has got a constant cross section. It's uniform. So if you have to cut it somewhere around there and so on, it's going to be the same area, and especially also if you do the cylinder, its cross section is a circle. So in order for you to find the volume of a uniform solid, you just take the area of the end and then you multiply that by the height. But now when you deal with solids that have no uniform cross section, and you will see that, for example, if you have to look at this particular cylinder here, you realize that as you go, the areas are not exactly the same. Okay, it's getting smaller and smaller, so it doesn't have a constant cross section. So in that particular case, this is the particular formula that you need to remember in order for you to find the volume of a pyramid or a cone, because they don't have constant cross section. It's different every time. Can you see that? So we are saying that in order to find the volume of such, you just have to take a third of the area of the base and you multiply that by the height, the perpendicular height, not the slant height do. And the volume of a sphere is found by the formula 4 over 3 pi r cubed. Now when you do Cambridge in Namibia, you are not going to have to memorize this formula. They will give you this formula, especially for this cylinder and the pyramid and the sphere. But you have to be a bit careful when you are using these particular formulas, because sometimes they might give you a hemisphere. Okay, that is half of a sphere, and then you need to multiply by half or divide by 2. So you must be a bit careful when you deal with that particular question. The next thing that I'm looking at is the total surface area. So we're going to talk about the total surface area, which is the area here for a cone, for example, is the area of the base, which is a circle, plus the area of the curved surface area. Okay, also this is one particular formula that also is given to you. You don't have to prove it. Then we're going to talk about pyramids as well. So when we do pyramids, pyramids are defined by their base. They are actually, like this is a triangular base pyramid because its base is a triangle. This is a square base pyramid because its base here is a square, and so on. This is a pentagonal based pyramid because its base is a pentagon. Then the area of such, you total surface area, you just find the area of the net. That means you open it up and you find the area, for example, here of the area of the square with all the four areas of the rectangles. Now what you realize is the base define how many triangles there will be. Like a triangular base means there will be three faces. A square based pyramid means there's going to be four triangles or four faces. All right, a rectangle consists of four sides, so also four triangles. And a pentagonal based pyramid means you're going to have five faces, five triangles that come and meet here, and the point they're meeting here is called the vertex. Then the next one that you need to know, as I said already, is how to find the area, or they will give you this formula to find the area of a sphere, 4 pi r square, in a question. So be careful that you don't confuse this with the volume of a sphere. So I'm going to do a few questions here. So I'm going to start with question one. And question one deals with a solid. It's a cone, but you can see that there is a part of that cone which we call the frustum. All right, so we are supposed to find the volume of this frustum. So if you complete this, you see you have a cone here, so you have like sort of a bigger cone, and then you have a smaller cone. So in order for you to find the volume of this frustum, you take the volume of the bigger cone with a radius of 12 centimeters, and then you subtract with the volume of the smaller cone here with a radius of 4 centimeters. So let's bring in the formula to calculate the volume of a cone. So we're going to take the area of the base. So if I do the big one, I take the area of the base, which is a circle, and its radius is 12. And I multiply that by the height, and the height is represented here in red. Then I'm going to subtract that by the smaller cone here. Okay, so if you look at what I did, I called the big circle a big capital R, and then a small one, I'll make a small r here. So I'm going to subtract them. So I just here, when you subtract, then this is what you get up, especially if you factor out the 1/3 pi. Right, so you punch in, and you'll notice for these questions I'm using the value of pi to equal 3.142. So you can still use a calculator value, but then you must give your answers correct to three significant figures. Right, so when you punch this in as it is with your calculator, you should be able to get 3,270 cubic centimeters. And this here is the volume of the frustum. Right, our next question here asks you to calculate the volume and the surface area of this hemisphere. Now you see a hemisphere is half of a sphere. So if I do the first part, where I know the formula is 4/3 pi r cubed. Now I multiply my formula by a half because this is a half of a hemisphere. And when you do that, you're going to end up with 2/3 pi r cubed. And now you can punch in your value of pi and your value of r. And when you do that to three significant figures, you should be getting 262 cubic centimeters. Then when you do the volume, or the area rather, when you do the area, the formula to calculate the area of a sphere is 4 pi r squared. But since this is a hemisphere, half of it, that's why you see I'm multiplying here by a half. So when I do that, I end up with 2 pi r squared. And now, you're not getting marks for writing down formula, and besides, these formulas will be given to you, but you will have to determine whether you're dealing with a sphere or a hemisphere. Right, so now you just punch in your value of pi, which I use 3.142, and the radius, which is 5 there. Don't forget to square it. And then at the end of the day, the answer is 157 centimeters square. Remember, we're dealing with the area. Question 3. They are asking us to calculate the material that is used to make this hemispherical bowl that you can see here. It's not actually below, right? It's next to it. So the inner radius is given to you as 5 centimeters, and the outer radius of the big one here is 5.5 centimeters. So the volume of a hemisphere, again, if you look at the volume of a sphere, is 4/3 pi r cubed, but a hemisphere I therefore need to multiply by a half. Okay, or divide by a half. So this is the formula that I'm going to use. So what I'm going to do is similar to the question I had previously. I'm going to find the volume of the bigger part of the hemisphere, and then I'm going to subtract it with the smaller one in the inside in order for me to find the material that was used. Right, so when I punch that in, you realize that you should eventually end up with 86.66 going on, obviously giving then your answer to 86.7 cubic centimeter. So you see here, I put a half here because I know if I deal with a hemisphere, I need to take half. And my capital R here refers to the big one, the 5.5, and the small one here refers to the 5. Okay, so then you can just basically punch them into that formula or into this formula. You should still end up with this particular answer here. Question 4. Here we have a ball that is in a box and it fits exactly. And that is very important that you do understand that particular part, because it's going to help us later to find more answers to certain questions. Right, so if we look at A, well, the ball we know is a sphere. So it's spherical. So when we find the volume of the ball, therefore we're going to have to find the volume of a sphere. Now we are told that the radius is 9 centimeters, so you just punch it in the formula. And then you give your answer correct to three significant figures, which is 3,050 cubic centimeters. Now they want us to find the volume of a box, and this is where this particular part comes in. This particular ball fits exactly in this box, which means it's going to be that this ball here or this box here has to be a cube, because it fits exactly here. All right, so this is exactly important for you to understand, because it fits exactly in that particular box there. Now, when you do that, you obviously have to know something, and that is that the diameter of the box right? The diameter of the box, because we know what the radius of the box is. The radius, not the box, but the ball rather. The radius of the ball is 9 centimeters. So if you have to find the diameter, because in order for it to fill the same height, so that is the radius, for example, inside. So if I add another one on top of that, I should get 9 plus 9, which is 18. And therefore 18 by 18 by 18. So it means we are dealing here with a cube. And we know how to calculate the area or the volume of a cube that has got dimensions of 18. You simply multiply the side, times the side, times the side, and then you end up getting, like I did here, 5,832 cubic centimeters. Now the third part, they want you to find the percentage of the volume that is not occupied by the ball. Remember, it touches all the sides, but there are some spaces left here because of the nature of the shape. Right, so you first find the difference then, and you realize you have got 2,782 cubic centimeters of space. Now we take that and we put it over the original, okay, over the 5,832, multiply by that 100, you should get 47.7%. Question 5 is about a pyramid, right? So they are saying here that ABC is the base. As you can see, this base here is triangular, all right, and then you have all the other information. So the important one here, they want us to write down a formula for the volume using this A and this B. Now because this triangle here is a right angle triangle, because the nature it is, right? So that triangle there is a right angle triangle, so this could be A, C, B. So I can have here A and B. So this is a capital B here. All right, so if you find the area of a triangle, you know that to find the area of a triangle, right angle triangle, is half times base times height. All right, so that half times base times height here is this particular part that I've calculated the area of this triangle, where A is my height and B is my base. It doesn't really matter because it makes 90 degrees, as you can see there. Right, so you clean this up and you should realize that you are going to get a third times a half, which is giving you 1 over 6, and times AH or ABH. So you just give your answer using that information. Then the second answer they want us to find, they want us to, now you simply just have to substitute the values for A into your formula, for B into your formula, and for H into your formula. And you realize that you get 40 cubic centimeters. That is if you want to find the volume of the pyramid. Right, this brings me to the B part. So let me bring the diagram here in B. It says this pyramid here has a rectangular base. Now it's very important that you can see that. So also I see that this rectangle here, the side TS is X and the side RS is X plus 3. And then P to O, that perpendicular height is 12 centimeters. So now they want us to write down a formula for the volume of the pyramid in terms of using the X. Now remember, the formula is find a third of the area of the base, and the area of the base is a rectangle, so we'll take a third of X times X plus 3, and then we're going to multiply that by 12. And that's what I've done here. So now what I did is I bring my 12 in front, so it's easier for me to find a third of 12, which is 4, and then I multiply this, and I'm going to eventually end up with 4x squared plus 12. Right, the second part says which, with the volume, which the volume is numerically equal to, when the volume is numerically equal to the perimeter of the rectangular base. So we know already what the rectangular base is looking at our diagram here. So it is going to be X here plus X plus 3, double of that. That's why I have it like that. All right, and then you clean that up, you're going to end up eventually with 4x plus 6 for the perimeter of the rectangle there. The 4x squared plus 12x comes from our previous part. That is the volume of the pyramid here. Now, when you have dealing with quadratic equations, you should always let them equal to 0. Right, so when I get to this particular part here, I will divide throughout by 2 so that I can get the required 2x squared plus 4x minus 3, which equals to 0. Now they are saying we are supposed to solve this following equation, and now they are saying you are giving your answer to two decimal places. So this degree of accuracy tells you this particular quadratic equation doesn't factorize. So I'm using the quadratic equation formula. All right, and when you use the quadratic equation formula, you should identify the value of A, you should identify the value of B, and the value of C. The A is here, the 2, the B is the positive 4, and the C is the negative 3 that you see here. And from now on, you can just simply punch them into the formula. And when you punch them into the formula, you see that I have a plus and a minus here because I'm going to get two values. So when it's positive, I get 0.58113 and so on. So then I give my answer to two decimal places. Now also, mind you, the value of x is a distance, and a distance cannot be negative. So this particular answer here, I'm not going to consider it because x cannot be negative 2.58 because it's a distance of a rectangle. So it does not work. So this is not applicable. So if there is a follow-up question, I'm only going to use this answer of 0.58 for the value of x. Right, so let us see. They're saying we're supposed to use our answer now. That answer, if I bring it back, was 0.58 to two decimal places. Now they want us to find the distance r is to s. It's very easy. You take 0.5 plus 3 more, and that should give you 3.58. Right, now they are saying M is a midpoint on ST, so it's exactly somewhere here. So let me just bring in that particular M. And now they are saying we're supposed to calculate angle PMO. So that's like a right angle triangle with my P being here and my O being here and my M being here, because it's going to make that 90 degrees there when you take this height with respect to that particular part. So it is that triangle that I am referring to that I have drawn here. Now, let me bring in what I know. I know that OP is equal to 12 centimeters. All right. And I know that I'm supposed to find angle PMO, which is represented by theta here that I brought in. Now I need to find the distance of OM. So I know that the distance of RS is equal to OM will be half of my answer for RS, because O to M, if you look at that distance here, it's going to be parallel to RS. So if you were to continue, for example, if you were to continue here from M right up to there, it should be the same distances. So therefore, that particular distance is going to be half of what I have in RS. Now I'm going to bring in that particular distance. So from here now, you are going to deal with trigonometry. And before you do anything, make sure that your calculator is in degree mode. And the correct ratio to use is the tangent ratio. And the tangent ratio, tangent of theta says 12 opposite divided by hypotenuse. This is the ratio we are talking about. All right, and the tangent ratio can be improper. So when you find the inverse of the tangent, you are going to end up with an angle of 81.5 degrees to one decimal place. Right, so here you just have basic questions. What is the name given to a pyramid which has got a circular base? That's very straightforward. This is a cone. Write down the formula for the volume of a cone using H and R. Well, it's a third pi r square H. Okay. Right, we have got a question here that deals with a rectangular box and it has got an opening here. Now, the external dimensions are given. Dimension is just another word for measurement. So we have got 2x on the outside here, x plus 4 here for the width, and the height is x plus 1. So now they want us to write down the volume for these dimensions. So it's very easy, you just then write them together. Now the second part is they want you to expand that particular answer. They must multiply them out. So what I did is I multiplied the 2x first to give me 2x squared plus 2x times 4, which is 8x, and then I multiply these two together. and then I multiply the 8x with each term in the second bracket. Eventually, this is what I have. So remember, this statement is important, the 2x cubed plus 10x squared plus 8x, because this is the volume of the outer side of this rectangular box. Right, so they are saying the box is made of plastic 1 meter thick. So the thickness they are referring to here is this particular thickness that you have seen me identify in red. So that's that thickness there in blue. All right, so that thickness here, it's very important that you understand. So if you have to write the internal dimensions, for example, so you need to be able to realize that, well, the distance from here is going to be 1, the distance from here is going to be 1. So if I have to find the new dimensions on the inside, it's going to be minus all those ones there. All right, so the inside, for example, is going to be here, this distance here, which has to be x minus 1, x plus 4, this whole one on the outside, but now I must minus this particular one here, and I must also minus this particular one here. And so applies that I did here. But the one under 4x plus 1, this simply just represents, the x plus 1 just represents the height. And the height then is just going to give me x, as you can see there. So because the box is not having a thickness at the bottom, okay, so it's just going to be that particular distance there. So we are just going to take off that particular thickness on top. Right, so the new dimensions that we're looking for is 2x minus 2, x plus 2, and x. Now they might ask you now to find the volume of the inside, and then we show that the volume of the plastic is 8x squared plus 12x. So first let's find the volume of the inside of the box. That means we're going to take these new dimensions and we're going to multiply them. And so when we multiply them, we end up with 2x cubed plus 2x minus 4x. Now, in order for me to find the amount of plastic or the volume of plastic, I will have to definitely do a subtraction here. So I must take the volume of the outside of the box, which I hope you remember from my previous, it was 2x cubed plus 10x squared plus 8x. And I will subtract with this volume of the inside. So I put it in brackets because subtraction changes everything. All right, the 2x cubes eliminate, leaving me with 8x squared plus 12x, which is the required answer for this particular question. Right, now they are saying the volume of the plastic is 1,980 cubic centimeter. You're supposed then to show that 2x squared plus 3x minus 495 is equal to 0. And once you show that, then you must solve this particular equation. So you're going to equate our answer from our previous part to 1,980, and then you're going to write it equal to 0. And now, in order for you to get into that form, you will have to divide it throughout by 4 in order to get what is the required equation. Now, solving this particular equation, I'm using the quadratic equation formula because it will not factorize, but it does factorize as well. But because I'm dealing with such a horrible big number, I'm comfortable using the quadratic equation formula. You can use any method that you are used to. Right, eventually when I do that, I arrive with two answers. One answer is x is equal to 15, and the other answer is x is equal to negative 16 and a half. Now they are asking you now to write the external dimensions of the box now. So we know what the value of x is now. So it's simple. When I take the 2x times the 15, I can't use the negative value, remember. I'm going to get 30. And then if I take x plus 1 here, 15 plus 1 gives you 16. And if I use the x plus 4, it gives me the 19 here. So the dimensions are 30 by 16 by 19 centimeters respectively. Right. This brings me to the end of this presentation. I hope that it has been worthwhile. I am going to post in the week the second part to this particular series.